This video will be the first one for our Chapter 3 opener, Maintaining Mathematical Proficiency Practice. And we're going to start off by reviewing simplifying square roots. Now, this is a skill that you may not have done in a while, but it was visited in Algebra 1 and Geometry, but it's not something you see very often, so you might have forgotten. So let's try this, and I'm going to show you two different ways. And you can pick which way works best for you and do whichever way you want. But the fastest way is to look at the square root, the radical, square root of 8, and find the biggest perfect square, that goes into 8. And those perfect squares are things like square root of 4, because it's 2. Square root of 9 is 3. Okay, square root of 16 is 4, square root of 25 is 5, and so forth, okay? So we want to see what goes into 8. Well, a square root of 4 can go into square root of 8, so this would be the same thing as saying square root of 4 times square root of 2, because 2 times 4 is 8. Well, I can take a square root of 4 and get 2, and I'm left with a square root of 2. So this is as simplified as this radical gets. Remember, simplifying them does not mean typing them into a calculator and, rounding to the nearest tenth. Okay, this is an exact answer, and that is how we simplify it, using perfect squares. Okay, if you have trouble with perfect squares, we can do it another way. So if I have 8, I want to think of the smallest prime number that I can divide out of 8. And it's an even number, so I know I can divide out 2. 8 divided by 2 is 4. The smallest prime number that goes into 4 is 2. And 4 divided by 2 is 2. So once the right branch is a prime number, you're done, okay? And all of these are in the square root. So for every set of them you have, you take that number outside of the square root, because this is what I have written here with these 3 2's here. Is the same thing as writing square root of 2 times 2 times 2, which is 8. And for every set of them, a 2 moves to the outside, so 2 square root of 2. So it's up to you how you want to do it, but like I said, doing it by perfect squares is faster, but it's up to you. All right, so number 2 here looks a little different. Now I have a square root of a fraction. Well, remember, square root of 7 over 36 is the same thing as saying square root of 7 over square root of 36. And I can't take square root of 7. It is prime, and I would get a decimal, okay? But I can actually take the square root of 36. It's our next perfect square over here. Perfect root, sorry. I keep saying perfect squares. Perfect root right there. So I know square root of 36 is 6, so I have square root of 7 on the top, and I have 6 on the bottom. That's as simplified as it gets. Okay, what you would want to do if you were doing with the little tree method over here, square root of 7 is prime. You can't divide anything out of it, so you wouldn't do 7, but you would do each square root separately. So I would say, okay, so if I had square root of 36, smallest prime number to go in 36 is 2, and 2 times 18 is smallest prime number to go into 18 is 2. It goes in 9 times. Smallest prime number to go into 9 is not 2. It's not even, but 3 does 3 times. Now, this last number is prime, so I'm done. And if I circle every pair, that means I'm going to have a 2 on the outside, and I'm going to have a 3 on the outside. Then I have no more of those prime numbers left, so I have nothing inside my root, but I have a 2 times a 3, which would be 6. So that's how square root of 36 simplifies to 6. And then, like I said, square root of 7 does not change, so this would still be the answer. Now, I'm going to help you out a little bit, and I'm going to do a problem from your practice. But before I do that, I do want you to pay attention that if this was a negative, your answer is negative. Don't drop those negatives. Make sure it stays with the problem, okay? All right, so let's move on to the practice. I'm going to do practice number 4. Okay, this is from the practice. And it wants us to simplify the square root of 147 over 100. All right, so so I'm going to have square root of 147 over square root of 100. Well, I can take a square root of 100 and get a nice pretty whole number, and I know it's 10. But I can't do that with 147. So what I like to do with my perfect squares, if I continue out this little chart over here, I know this would be 49, then I'd have 64, I'd have 81, I'd have 100, okay, and we can keep going. But I want the biggest prime number that can go, perfect square that can go into 147. So I'm going to look at it this way. I'm going to go, okay, 147, I know I can't divide it by 100 and get a whole number. So I'm just going to keep working my way towards the smaller numbers. So I can't divide it by 81 and get a whole number. If I divide it by 64, I would still get a decimal. But I can divide it by 49. If I divide 147 by 49, I get 3. So 147 is the same thing. Square root of 147 is the same thing as saying square root of 49 times square root of 3. Well, I can take the square root of 49 and get 7. I'm still left with the square root of 3, and we already simplified the bottom to be a 10. Okay? If you wanted to do that in the other way, where you have a square root of 147 on the top, and we have a square root of 110, and we just need to simplify them, and you'd have to remember which one's on top and bottom. Okay, 147, smallest prime number to go into it is 3. If I divide by 3, I get 49. Smallest prime number to go in 49 is 7, and 7. So here's my set. That means on the outside of my radical, I'm going to have a 7, but then I only have a single 3, so it has to stay inside my radical. All right, and that's how we got what was on the top. And then for the square root of 100, smallest prime number is 2, and you get 50. Smallest prime number is 5, and you get 25. Smallest prime number is 5, and you get 5, which is prime. So every set, I'm going to have a 2 times a 5. I don't have any left inside, so that means outside I have 2 times 5, which is 10. And that's what we got up here. All right, so I want you to go to the practice. I did number 4 for you, but I want you to continue, and I want you to do 1 through 8, all of those. Obviously 4 is done, so 1, 2, 3, 5, 6, 7, 8. And then move on to the next video.